Um, hey everybody, as was just said, my name's Joel. I work for Cure International. And if you saw the video from earlier, we're a nonprofit organization that runs hospitals and programs in 29 countries around the world. We focus on taking care of kids who need surgery. But a little bit about me. I'm a developer by trade. That's what I get up in the morning and love to write code and don't always get a chance to, but I've been doing that work since 1998, and I'm hoping someday to be really good at it. So the information I'm going to present in this talk, which is called Surviving the Offline Apocalypse, yes, it's zombie themed, is the collaborative work of the entire team of people that I work with back at our Cure headquarters in Pennsylvania. But it's primarily based on a guy named John Kleinschmidt, who's our lead architect. He actually was originally supposed to come and give this presentation, but because of some health issues in his family, he wasn't able to be here. So if you like the presentation, if you like what you saw, then you should go ahead and tweet at jkleinsc, because he's at home wishing he could be here, but it's a good thing that he is where he is. So this is called Surviving the Offline Apocalypse. So first of all, we're going to talk a little bit about offline. So why does offline matter, right? We're here at a conference to talk about the future of software, and why are we talking about something that isn't connected, right? So first of all, of course, sorry, just a minute. Let me go back to my previous slide right here. First of all, of course, in the U.S., we've got pretty good connectivity, but surprisingly, most conferences that you go to, right? I mean, the Wi-Fi, you lose Wi-Fi all the time. Actually, in the healthcare industry, there are some significant issues and times where it's not possible to have connectivity. And the reality is, there are circumstances where your server just goes down. And for us, we see that there's actually a real purpose behind offline, not just in the context of what we're doing as an organization trying to do work across the world. I mean, in these very remote areas, but also we see it as sort of like an opportunity to open up a brand new market. So if you could solve what's happening from an offline perspective and still work with cloud-based technologies, there's a possibility, maybe even to make it a very profitable activity, not for us, but for other people. All right, so also, more sort of germane to who we are as an organization, why does offline matter to Cure, right? So at Cure, we treat a condition called hydrocephalus. We treat conditions like a whole pile of orthopedic and neurosurgery and reconstructive needs, but one of the major things we treat, particularly in our hospital in Uganda, is a condition called hydrocephalus. Have you ever seen pictures of the child who's on the left, on my right? It's actually a condition that's caused by the fact there's an infection in their brain. It's not allowing cerebrospinal fluid to drain properly through their body, and that's what's causing this child's head to expand. It's not just something that looks odd, it's actually going to kill that child if they don't get surgical treatment. So it's actually like crushing brain tissue, it leads to blindness. The mortality rates say that you're not going to survive after 5 years old, and if you don't get it treated sometime relatively quickly, you're going to experience permanent brain damage. But the really good news is that it is surgically treatable. There's a surgery that we do. Actually, we do more of it than probably anyone in the world in our hospital in Mbale, Uganda, and actually in locations in 15 countries across the world, where kids like Tom got the care they needed. And actually, he's in school now. He's doing well. He's going to have a normal life, what normal looks like in Uganda for him. So for us, it's a very personal topic, because this ability to do offline is helping us do that work better. So when we talk about the problem, what we had as an issue was actually that we needed to create a ability to manage medical records across a network of this hydrocephalus treatment that we provide. So if you look at our map, it's hard to see on this thing, but we've got a bunch of green dots, and that's the places where we have a hospital. Well, developing world infrastructure is complicated enough. When you own and run the facility, it is very, very complicated, relatively manageable, but still complicated. But we also have a whole network of surgical programs where we don't own the facility. We have a surgeon that's working with us. We have a care coordinator that's coordinating all the interactions and follow-up visits with patients. And so how do we deal with a problem where we need to do record keeping in a setting where we don't have IT support on the ground? Frankly, even if we did, it wouldn't be very good. And so we need something that's going to be like very low maintenance, but it's also going to deal with this complexity, which is that this internet connectivity is certainly, I'd say unreliable is a kind word to use when you talk about some of the challenges we face. So for us, there's sort of a couple different ways that you could potentially attack this, right? We need to have something that's easy to manage, that's easy to deploy, it's portable. And so initially we started thinking about like, well, okay, so we'll just put a lamp stack on a laptop and like have people just ship those devices out around the world. But that comes with a lot of problems because now how are you actually going to manage the updates on those systems? We don't have IT support on the ground. We really need to find something that's going to be resident in the browser and it's going to work online, even in a setting where we might not be, in fact, online. So that's where the solution comes in. We created an offline first electronic medical record system. So this whole system, we took sort of like focused our paradigm on this idea of like offline first, right? So by offline first, what we mean is we're assuming that internet connectivity may or may not be there. So after you load up the initial content of what it means to run this system in your browser, you're just sort of working with that environment. Now, if online's there, that's good. It's important because it's actually the critical way that all the information is getting back to a reporting service. But all the technologies that are available in HTML5 and modern browsers make it possible to actually build a system that we're using. This isn't just sort of a theoretical thing. It's deployed across the 15 places where we're doing this hydrocephalus care. So you can see, we're tracking things like we've got photos attached to it. There's a charting function, and it sort of looks and sort of feels like you're actually sort of working in a desktop environment, but it's actually running in Chrome, and we're distributing Chromebooks out to these folks in the field. So we've got a low-cost device that's easy for us to manage, and we can centrally authenticate off of our Google Apps domain. Okay, so to the point of surviving the offline apocalypse, right? So anybody knows who's seen a zombie movie, there are rules if you're going to like make it in a world that has been ravaged by zombies, right? And these are the rules. So you got to learn how to live off the grid in a fortified shelter. You have to have some place to store your supplies. You have to have adequate weaponry, like to get around in zombie land. And then you have to have an escape plan, and you have to follow it. And that's sort of some of the things that we did in the process of building this platform. Okay, so I'm going to go through just a handful of technologies that are available in browsers, talk a little bit about support, and hopefully this will be useful for you. So first of all, you got to live off the grid. And this is all about the application cache. The application cache is basically a way of helping us determine the context of what our app in the browser is going to need in order to run in an offline environment. Now, if you've worked with application cache or you've heard nastygrams about application cache, I could tell you some of those things are true, that it can be sort of painful to work with, but it is manageable, especially in a situation where you're dealing with a one-page app. So what happens for us is we load up the context of everything that's there, and then that's sort of the basis of how the electronic medical record system is going to run going forward. So let's look actually just at a couple like simple code examples, right? So you can see in order to work with application cache, one of the things you have to do is actually declare that in a manifest file. And the really important content that is right here, like in this section that is titled cache. You're basically defining, here's all the resources I need in order to make my app work. Now, there's a couple things, sort of some gotchas. If you get a 404 on any of the resources, it's going to crap out on you. So that's not a good thing. So your app needs to load up properly the first time. And it will override, unless the manifest file itself is updated, it's going to override anything that's in your browser cache as well, right? So like basically once you've got these resources and this file declared, you're going to have to do something else in order to be able to deploy a change. But that's really easy to manage, and we do that in our app as well. So what we do is go ahead and create a dynamic application cache files. So if you happen to be online and you are in a position to be able to pull down an update, the system knows how to basically refresh the resources. And in this case, what we're doing is we're using a really simple algorithm to figure out if a file changed, and if it did, go ahead and create a new timestamp that's associated to bust the cache, essentially, and pull down new resources. So that helps us deploy new versions of this record system. Okay, so just a couple things about browser support, right? So good news here is application cache is actually pretty broadly supported, right? Not supported in older versions of IE, but across the board, actually, you're doing pretty well. And if you're interested in more information about application cache, I highly recommend some work that Jake Archibald has done on this issue. If you Google application cache as a douchebag, you'll find a really great article. It's pithy, but actually really accurate too. It's something you can work with, just like your friend who might be sort of a jerk, right? Okay, so next, if we're going to live off the grid, the next thing we need to be able to do is store our supplies. And for us, that means that we're going to use IndexedDB, right? So IndexedDB uses key value pairs in order to store object structures in the database, or in its database, local in the browser. And it's got an indexing function, so it's possible to search. You can imagine in our setting, so in our hospital in Uganda, we've got 10,000 records from all the history of systems, and we don't always necessarily load all those directly in that app, but you're working with a pretty broad set of data. You need some simple searching functions. Okay, so a word about this. So IndexedDB is highly asynchronous, right? So if you're used to working with XHR requests, this isn't a big deal, but just be aware it is going to have an impact on what happens in your interface. So just keep that in mind, and there's my first meme. So, okay, so just a couple code examples. So this is just a real simple example, and all these slides are available up on Cure International's GitHub account. You can go ahead and download it. There's a link at the end here, so if you want to go ahead and look through this. But essentially, what we're doing here is we're opening we're creating and opening a database called My Database, and there's a couple different things that happen from an event perspective that help you sort of define the structures of what happens in IndexedDB. You create object stores, which are essentially for people in the SQL world. They're tables, and then you create indexes on those object stores in order to make searching easier. And one of the events that fires, it might be hard to see, but is that on upgrade needed. So when we're in a situation where we've pushed a major change to the electronic medical record system, it's possible for this event to basically help us migrate the data. There's new definitions about the object structures, and so it makes it pretty manageable. And then here you can just see a really simple example of actually doing something with the data. In this case, we've got a cat memes object store that we're using, and this is just an example of adding and retrieving an item out of IndexedDB. And then also I mentioned, of course, that there's the ability to do searching. So you can define indexes. You can define both the unique index as well as sort of categorization. So if you want to find everything that's tagged with a particular type of category, the indexes make it really easy for you to be able to search through that. And then lastly, I've got to give a shout out to the Chrome developer tools. They have some really great tools in order to have some clear insight into what's in your IndexedDB, in your object stores, as well as actually some really good support for both application cache and the file system service that we're going to talk about in a minute as well. Okay, so now, browser support. So we're not as lucky as we were with application cache, right? So in this case, we've lost iOS and Android, and because they're using actually a different solution, which is WebSQL. But the really good news is there's a polyfill, right? So you can get to a place where basically we're back up to par with what we can do with application cache, and basically everything below IE10, and I think some versions of Opera don't support it, but otherwise, the real world is ready for you, right? Okay, and then Finally, or well, not finally, third, we need adequate weaponry. So we're going to use a file system. We need some way to be able to retrieve and store files, and ultimately some way to be able to faithfully pull them in and out of the system in order to get that up to our medical record solution. If anybody is curious, that's actually a Nerf gun, which I think is pretty awesome. So. Okay, so just a quick example here of like working with a file system API. Again, it's asynchronous, so the whole process of you basically you have to get the browser to define. Okay, we need a set of space that we're going to be able to use for files. You can choose to make them persistent or temporary files. We're using persistent because we're storing images, like either smaller images from scans or particular pictures of the patient, and those all need to be tied in with their records. So you can just see an example here where you get a handle, go ahead and write the file to the file store, and now it's there, you've got it, it's actually being stored in your browser. And then right here, we could see an example of actually taking this file that's stored in our file store, well, our file system, and then actually pushing it through an AJAX request back to a PHP call in order to actually store it in our reporting service. So architecturally, like what we're dealing with is like we've got a server that's sitting in the UK, and that actually is a central solution that's managing all this information, but everybody's got what they're working with generally local on their browser. Okay, so now when we get to browser support, we are it feels like we're sort of screwed here, right? I mean, with file system, this isn't going to work for anyone basically except Chrome, which doesn't hurt us, but it hurts the viability of you doing something significant with it. But good news, there's a polyfill, right? So with the polyfill, now we're getting to some place where it starts to feel like we've got some sort of manageable way to be able to work with this file system API, but we're still not quite there. But there's a polyfill for the polyfill, right? So there's actually some work my colleague John's done to work with the polyfill that basically clones IndexedDB functionality with Web SQL, and it's actually handling the binary objects in a lot more faithful manner. It's not 100% on par with structured cloning algorithm, but like it's good enough, really, really good enough for us to be able to do what we're trying to do. And if you want to see an example for that, you can see it in John's GitHub. Okay. Now, so last thing, everybody knows when you're in Zombieland that no matter what plans you've made, it is absolutely critical that you have an escape plan. And you trust no one, know your surroundings, monitor your exits, and you got to be able to think on your feet, right? And so this is all about how are we actually going to interact with the web and actually get the data that's sitting here on this very fragile piece of technology and get it into the cloud. Okay, so first of all, what we need to be able to do is know if we're online, right? And what we do to do that, how we do that is we go to the navigator.online property, and I'm going to just read the definition for navigator.online. Returns false if the user agent is definitely offline, disconnected from the network. Returns true if the user agent might be online. The events online and offline are fired when the value of this attribute changes. Might be offline, might be online. I mean, it's 2013 and we don't really know if we're on the internet or not, okay? But if you think about it, it actually makes sense. I mean, there's all sorts of things that could interrupt your capability to get to the service that you're actually trying to reach, which fundamentally, whether or not the internet's up or not is really irrelevant to your app. What's important is, can I reach the place that I need to get to? But that's okay because XHR's our friend here. So this is just a simple example of how we can use the navigator.online property and the Windows on and off events, online and offline events, to basically help us figure out, are we in a position to actually talk to our cloud service and get this data out of this laptop and make sure we're managing all the sync issues, right? So the code's pretty simple there, and obviously the AJAX request, if we can reach the resource that we were trying to reach, like, we're online as much as we care, right? So that's sort of that example. And again, you can go back to the slides to be able to see that a little bit better. Okay, but it's more than just knowing whether or not you're online, right? You've got to know, you've got to be able to know your surroundings. You've got to be able to monitor your exits. You need to be able to, you need to have some clear sense of really what's going on in your surroundings if you're going to survive the offline apocalypse. So for us, that's all about what we're doing from a monitoring perspective with New Relic. So there's two different things. We want to both have a clear sense of what's the experience for the user right there in Uganda, in Zambia, in Bangladesh, and then also have a clear understanding of what's happening server side when those sync requests are coming through, and how's that data actually being processed. And we, of course, as is always the case, we ran into an actual real-world example that caused some significant issues for us and made us really happy that we're New Relic customers. So to get some sense of what's going on from the client perspective, right? Browser traces are your friend, right? So we're actually, again, it's hard to see, but we're actually breaking this down based on geography. So we're getting some clear sense of from a network perspective, from the user's experience perspective when they're loading this system. What's the experience like for somebody in Uganda? What's it like for somebody in Zambia? What's it like for us here in the U.S.? And that helps us get some sort of first diagnostic tool to understand how is this application actually working. But then on the other side, we need to be able to understand, based on these queries, based on what's happening from a sync perspective, what's actually happening on the server. And that's where key transactions come into play. So we've got, in our system, we have key transactions that are broken down for every single locale that helps us sort out how much time did that sync actually take. And in our circumstance, actually, we had pretty early on when we deployed in Zambia. So we've got a 2-minute timeout, on the client side, for a sync request. And you think, gee, I really hope it doesn't take 2 minutes. Well, it turns out actually for a while, the system it wasn't syncing properly, right? So we were trying to get some clear sense, what's the experience on the browser, what's really going on. It turned out we had a query that was going haywire. Of course, the key transactions told us exactly what was going on, and it was possible for us to think on our feet. So the numbers here might be a little bit hard to read, but you can see that before we were dealing with as much as a 78-second time to actually execute on this particular query, and we were able to roll that down to about between 1 and 7 seconds to solve that problem. And the amount of time it took us to actually track down that issue and solve the problem, as you guys have all experienced, anybody who's a customer, it was a matter of hours. And the next day, we had a change rolled out that was going to solve the problem, and Zambia finally was up and running on the system properly, right? So, okay, last slide here. This is really one of the things that this is super heartwarming, right? Okay, these people are all survivors of the offline apocalypse, right? These are the first folks that went through our training program when we launched our offline first medical record solution. We ran a training event in Uganda, and actually the guy who architected the solution is the guy in the back corner there who's not here today, but he was there to actually run this training event. All these people are from countries all across Africa and Asia. They all are actually using a system where they're working offline first, but all their data to the tune of about 9,000 to 10,000 patients is being stored in a cloud-based solution that's sitting in the UK, and we're doing some really amazing stuff from a research perspective with partners at Harvard, Boston Children's Hospital, and Penn State to actually improve the quality of care for kids that are dealing with this deadly condition called hydrocephalus. So that's all the content for my talk, and I've got about 5 minutes if it turns out there's anybody who has any questions. Questions. Yes. I am, yep. Oh, thank you. Yeah, actually, the question was, am I Tango Llama? And the answer is yes. So, yeah, the really awesome thing about that, and please, nobody go punk me now, is no matter how late I show up to any particular social networking site, my handle is always available, right? So that's the reason I use that. So there's a lot of Worralls.
So in the offices around the world, what's your most common form of internet connection? Is it dial-up or cellular or broadband?
Okay, so for the Hydrocephalus program, and actually we're taking this exact same system, we're rolling it out to our Club Foot program, which is an even bigger problem. It's like 300 clinics. So like in those situations where it's remote, a lot of times it's 3G modems that we're using. But in the hospitals, we tend to pick really unreliable ISPs. There's not a lot of, the trouble is there's not a lot of competition in developing world internet. And so, yeah, finding somebody who will pick up the phone is the most complicated thing. So the most reliable thing, frankly, is 3G modems right now. But that's also expensive, especially when you're talking about like the facility infrastructure. So it depends on where we're working. Yes?
Yeah, it's a coffee break.
Do you have any best practices around reliably in your dev environment simulating really slow connections? Because I feel like your use case is like this is awesome, but like I've even seen, as someone building software that's predominantly in like North America, Asia, Europe, we've got people on really slow connections everywhere. And so I like this idea of like maybe thinking first, like, okay, plan for low connectivity. And so I just wonder if you could elaborate a little bit more on that.
Yeah, okay, so from an environment perspective, so like our whole team, I don't know if you saw the video, we're 4 people, right? And like this isn't the only project we're running. It's like we're running about six projects. So for us, in a lot of circumstances, what we'll do is like we'll slow roll changes into production because we're not trying to replace anything that exists already. We've done some, we've worked with a couple simulation tools to like try to like create that really janky internet feel. It hasn't been as productive as just monitoring what's happening. Like once you like make the best decision you can, monitor, like really pay attention to what's happening, and have a deployment mechanism to make it possible to like get a change out quickly. Yeah. But if you're curious about some of those tools that we've used, you could write my colleagues, jk@cure.org. So.
How do you know that the latency is caused by on the server side versus the transport layer?
I'm sorry?
How do you troubleshoot things like if the latency is being caused by the code on the server side versus the connection itself? You know what I mean?
Yeah. Oh, yeah. So that's one of the things New Relic gives us, actually. So we've got a really clear breakdown of like what the execution time is from a server perspective versus actually when you look at like the browser traces. One of the things you can track through is some sort of metric around network latency. So there's actually the monitoring tools actually do an awful lot of that to solve that problem. There's no way in the world we could figure it out without New Relic. Okay, one more question.
Can you go into more detail about the problem you had where you had 73-second load time and you reduced it to 3? Like, what was the problem? How'd you do that?
It was an epically bad decision on the query. So like there was, MySQL database, like weren't paying attention to the fact that that there was, I think it had something to do with like the lack of an index on a particular column that we were searching on, and we just weren't running across it in any other setting. It had something to do with like their specific use, and so it was actually pretty easy to sort out. We just, we needed the monitoring tool to be able to address it. And we one more question or no? Or, yeah, I've got 2 minutes. So yeah, just go ahead.
How do you do your synchronization?
Carefully. No, okay. So the question was, how do we do our synchronization? Yeah.
Do you have to compress the data, or like do you have algorithms to reduce the amount that you actually have to synchronize?
Yeah. So the question, do we do anything like from a compression standpoint in order to make those requests as small as they possibly can be? Yeah. So we do a couple different things, like with the way we choose to store. So really, it's the data itself is not that significant. It's JSON data. Like there's a set of, we're storing as many fields as we need. All that data needs to get someplace. with the files that we end up uploading, what we'll actually do is actually send the smaller version, and then I think in a separate request we send larger version. So if that fails, at least we've got some sort of like backup of that solution. So yeah, we're not doing anything like, you know, there's no cyborgs or anything, but yeah. So any other questions? All right. Well, thanks so much for coming to my talk and for listening, and yeah, you guys have been great. So.